Okay, and right, so we oh, it looks like we're zoomed in too far, huh? Yeah. Um, is that is that okay? All right. This is the foot of my tripod here, which tends to be in the way. So yeah, we proved that the circular angle is half the central angle subtended by an arc. We looked at a degenerate hyperbola. It's got, bottle of Ripple in a paper bag under the bridge. Um, and yeah, so it's sort of degenerate in the sense that the graph is not a curve, it's just these two straight lines, which is actually a conic section, right? And then we looked at, yeah, so we kind of wound things up pretty nicely here with the parameterization of this ellipse, which was number 12 in the exercises. And let's then skip over to, what have I got here? Um, yeah, these guys. So I'm going to close that and then zoom in a little bit. It doesn't, okay. I think what I want to do here is go to Trig and say I'm going to add, oh, I forgot to publish that. I'm going to add a homework, which is hyperbolas. Uh-oh, I don't see it there. Okay, why not? I see ellipses. Maybe I didn't publish that. Okay, so let's close that and go back to assignments. And under homework, we should see hyperbolas. Yeah, which looks like it's published. If I open it up and say, well, um, assignment settings, it's published, it says. I could save it again, I guess. I don't know what the point of that would be. So if I go back to modules, still figuring this Canvas stuff out, folks. Sorry. I'll get it by next week. The end of next week, I'll have it down. Okay, so this is a homework, which there should be something under. Is it alphabetical? Oh yeah, hyperbolas. Okay. So add that item. There it is. Okay. So now we can get to it from this week's module. And we can close this part. And turns out that, yeah, okay, we can zoom in a little bit. All right. So there's 12 questions here. A hyperbola has vertical transverse axis of length 18. So what does that mean? In terms of we want to get the equation of it, right? That means A is 9, right? Because the length of the transverse axis is twice A. So A is 9. And the asymptote is y equals 6/7 x plus 2. And, sorry, that and is hard up against the 2, isn't it? There should be a space there. So the other one is, okay, so let's take this over to our workbench here, right? Yeah. So if we know the, so this is hyperbola homework. And, this is sort of, this is good review material since we're likely to sort of emphasize conic sections maybe a little bit on the exam. So the hyperbola homework, should we want to zoom in a little bit more now? I think we're zoomed out too far. Oh, that's out. Okay. And okay. So we know that given transverse axis of length 18, then we know what? We find A is equal to, well, twice A is equal to 18, and so that's equivalent to saying A is equal to 9, right? That's a 9. This is an A, and that's a 9. They look kind of similar, right? Okay, then asymptotes are, this is kind of a tricky one to open up with, right? So because this is not centered at the origin, right? So y equals negative 6/7 plus 1. Okay, that means the set indicating, maybe I should say, if I'm going to get a proper narrative going here, that where's the center? Well, that's sort of given by these intercepts, right? Is that right? I have to think about that for a second. So I guess we need to find out where is at the intersection of these, right? Sorry, this should be an X here. Sorry, I left out the X. How are we doing? Okay. If you have a question, you can put it in the chat or just blurt it out. The point of intersection of these, right? So how do we find the point of intersection? Well, at the point of intersection, the y coordinates are equal, right? So at that point, y equals y, which is equivalent to saying 6/7 x plus 2 equals negative 6/7 x plus 1. Let's multiply through by 7. So we have 6x plus 14 equals negative 6x plus 7. Is that good? All right, so why did I multiply through by? Obviously, I wanted to clear out the fractions, right? It's a lot easier to work with integers and fractions, and we get an equivalent equation with just integer coefficients, right? So now 12x is equal to negative 7, I guess, right? I mean, I'm just, adding 6x to both sides and subtracting 14 from both sides. And that implies that x is negative 7/12. Jeez Louise. It's a number. And so y is going to be 6/7 times negative 7/12. I could plug into either one of these, right? But this one, so I'm plugging in here, right? Y is given by both of these, and either one will do. So I plugged into the first one. So the 7s cancel. That's nice. And the 6/12, that'd be negative 6/12, right? Is going to be negative 1/2 then, plus 2. So y equals 3/2, and the center is at x is negative 7/12. It is what it is. And y is 3/2. By the way, I'm curious. Did I get a response on that question about? Yeah. There was some discussion about whether the final exam should be cumulative or comprehensive or not. And generally speaking, it is. That's just sort of my personal policy. And I think Kelly was right that it's not necessarily a school policy. So I can't say, well, I just do it because I have to. But I think it seems sensible to me, right? I mean, it's a capstone for the course. So it should be comprehensive. And so that includes, algebra like we're doing here, and conic sections, analysis of conic sections. So we got a center point, right? So this is going to be HK. What else do they tell us? Find the center of the hyperbola. its focal length, and its eccentricity. Oh, okay. So they don't actually ask us to find the equation? Yeah, okay. So um, I think the eccentricity is C over A again, right? We didn't talk about eccentricity, but it's a measure. Well, what could the equation be here, right? So the equation could be either, well, let's do this. What do we know so far? And they don't ask for the equation, but I'm curious. Uh, will look like what? Well, in general, it's x minus h squared over. Now this could be either a or b depending upon whether the hyperbola has a vertical transverse axis or a horizontal. Let's assume that it's horizontal. Okay, so that a goes with x um, and y minus k squared over b squared, and that's got to be 1, right? So we know h and k are negative 7/12 and 3/2, right? We know a is we found a up here was 9, right? We don't know b. Can we find b based on those? Well, we don't know a point on the parabola, on the hyperbola, right? We know where the center is, but that's not a point on the hyperbola. So we'd have to have more information, right, at this stage. So we could say, yeah, we know it's x minus negative 7/12, which is going to be x plus 7/12, and we know a is 9, so that'd be 81, and we know y is 3/2. Sorry, this k is 3/2, right? But we don't know b, and we don't know a point on the parabola. Sorry, I'm writing invisibly. Um, and so that's the best we can do at this stage, right? We'd need a little bit of extra information. But what do they ask us? They ask us for the center, they ask us for the focal length, and the eccentricity. Yeah, to get the eccentricity, we'd have to know. Um, okay, so we do know enough to find b, don't we? Yeah, I was wrong about that. What is it that gives away the value of b? Well, we know the slope, right? And if a goes with x, then the slope is b over a, right? So since the slope of the asymptote, so I was wrong about not knowing enough, is it's going to be b over a in this case, right? And that's going to be 6/7. We can say, well, look, we know a, we don't know b. We know a is 9, right? So that's an equation we can solve for b. It doesn't come out pretty. I mean, yeah, it's pretty. All numbers are pretty. Um, so, so what can we say? This implies that b equals 54/7. It is what it is. It's a very pretty number. Put it in a box. 54/7. It's not every day you come across 54/7. That's about 7 and 5/7. It's about, closer to 8 than 7. All right, so then we can plug that in, right? And we get x plus 7/12 squared over 81 plus, oh, yeah, now we're going to have to square this beautiful number and get an even more beautiful number. The square of 54 is 2,500 plus 40. So 2,540 plus 16 is 2,556. and the square of 7 is 49. Yeah. Oh, sorry, I'm off screen again. Maybe I should have just put in the 54/7 in parentheses and put a square on it and said, yeah, there's the square of 54/7. You don't really have to compute it, right? But this is now the full equation, right? So we could set about graphing it if we wanted to. Let's just answer the questions though, right? So now that we know both A and B, we can go ahead and find C. I think part of what's going on with this problem is that it's parameterized. And so we just got unlucky and picked some parameters that didn't really mix well together. I think that's probably going to be the case, yeah, most of the time, right? So you'll get different numbers, I would expect. And so, you won't be able to just cut and paste this in, but you can follow this process in the same way, right? So what's C? Well, C squared on a hyperbola is A squared plus B squared, right? So that's going to be 81 plus 2,556 over 49. Oh, joy. And should we get a common denominator? Well, 80 times 50 is easy, right? That's 4,000. So we can say, let's do a little scratch work up here. 81 times 49 is 80 plus 1 times 50 minus 1. So that's 4,000 minus 80 plus 50 minus 1 altogether, right? And I guess we can say that's 4,050 minus 81, which I guess 14 minus 8 is 6, and so that'll be a 9 and a 3. So this is 39 over here. I'm back over here. I guess I need to tilt this up a little bit. Gravity. So what do we get? 3969 plus 2556 over 49. We just got a common denominator here. That's why I was multiplying 49 times 81, right? And presumably I did that right, so that we can combine these and get what, 15, 12, 15 again, and 6 over 49. So that's C squared, right? And so C will be the square root of that, which I think will simplify a little bit. Let's go over here and say C is the square root of 6525 in the year 6525. What do we got? So is that a perfect square? Kind of looks like a perfect square. It's divisible by 25, right? So 6525 is 25 times what? Well, it goes in 200 times 150, so that 5 times, that's 125, so 25. Oh, I know it goes in evenly. So 25 goes into 65, 25 twice, leaving 152. Then it goes in 6 times, right? Yeah. 7 times? No. Yeah, 6 times. And 6 times 25 is 150. Okay, so that leaves just 25, and so that's a 1, right? Is 261 a perfect square? What did I write up here? I don't know. That's wrong. I've lost me eraser. I meant to factor this as a product of 25 and 261. Yeah, okay. 261 is not a perfect square, is it? No. 200. No. Do we have nearby perfect squares? 16 times 16 is 256, right? So it's close to that, but no cigar. So we can say that this is 5 times the square root of 260. Simplest radical form, folks, right? For C. And so the eccentricity, mercy, this problem is like a tough one to start out with here. In general, it's going to be C over A. Is that right? I think it's the same formula as for an ellipse, right? But the thing is, on an ellipse, C is less than A, so the eccentricity is between 0 and 1, whereas on a hyperbola, C is bigger than A. And so this is going to be 5 times 261 divided by 63. A is 9, right? And so I imagine that this is bigger than 9. Should we compute it to see approximately what that is? Do they? Yeah. Well, I don't know. Let's try putting in my answers here and seeing if they're wrong. I'm afraid they might be. The center of the hyperbola, -7/12, right? I'm going to enter that in here. I'm typing it in. And this is 3/2, right? Hoping those are right. The focal length is, well, they gave us that, didn't they? Oh, the focal, that's a distance between the foci. Mm-hmm. So that's going to be twice C, right? There's a plus or minus this in general, right? So that's the distance from the center to the focus, and the distance between the focal. What's the focal length? Jeez, let's go to the text and take a look at, make sure we're getting these things right, huh? So where is the text? That's here. Let's bring it up. And I'm going to scroll up a little bit. These are shifted parabolas. So I think we want to go up here and say, search for, find focal length. Is that even discussed in this text? Oh, no. It's searching, it's searching, it's searching. It's going through 1,000. Oh, focal length on page 790. Okay. Can I enter in 790 or do I have to scroll to there? Go to page 790. Okay. So the focal length on a parabola, we know what that is, right? That's the distance across the parabola at the focus. Oh, mercy. So I'm going over here now. And it looks like maybe they don't have it on. Is there another? I think that was it, huh? Yeah, page 790, which refers to parabolas. So the focal length, focal length of a hyperbola. I'm going to guess that that's the distance between foci, right? Okay, let's just take this first one here and find focal length in here somewhere. Oh, I thought I was searching. Search site, okay. Yeah. Right, the distance between the foci, the segment F1, F2 equals twice C is called the focal length. Right, I was right. So the focal length is going to be twice C, which, yeah. Whoops. I'm trying to type in square root. I'm off. Okay, square root of 261 divided by 7, huh? Okay, the eccentricity, that's C over A, which is 5 times the square root of 261. Provided I haven't made any arithmetic errors, over 63, and resistance is futile. Oh, well, I got the center right, but it looks like I've screwed up. So maybe I should use a calculator, huh? Do I have a calculator? Yes, I do. So let's try recomputing that with the calculator. And I think I want to make that larger, don't I? Yeah. So what do we have? We have A is 9. So I'm going to just store that into the variable A, okay? B, well, we found B by saying that it's the ratio of B to A is the slope, right, of the asymptote, which is 6/7. Yeah, A goes with X, and so B goes with Y, and the change in Y over change in X is going to be B over A. We could go back to the text and be sure of that, right? I've got to scroll down here to past the ellipses into the hyperbola, and there's a little box, right, containing the information. So if A goes with X, then the slope of the hyperbola asymptote is B over A, right? So that's 6/7 in our case. And so since A is 9, we multiply by 9 and get 54/7. Okay, so B is 54/7. So I'm going to put that into my formula on the calculator. So I'm going to type in 54 divided by 7, store that to B, and then I'm going to say I want the square root. Well, let's say I want A squared plus B squared. And I want to convert that to a fraction to see if I got the right fraction. See if it will. Sometimes it won't, right? I think that's on the math menu. So if I go here and then I say miscellaneous, no, that's not it. More, no, it's not there, huh? I thought it was on the math menu. Maybe it's under the number menu? No. Oh, where's the convert to fraction? Anybody know offhand? Nobody has the 86? Probably not, huh? Is it under, well, you can always go to the catalog. I'm just kind of surprised it's not on the math menu. Did I look under miscellaneous? More? Oh, there it is. Convert to fraction. Okay. Yeah, 6885. Oh, yeah. See, I screwed that up. Over 49. You let me screw it up, though, so it's your fault. So where did I screw it up? I guess the product of 81 times 49. What's 81 times 49? Use a calculator. I was trying to be clever. Do it by hand, right? 3969. That's what I got. So we're going to add 54 squared to that, right? B is 54/7. So And add 54 squared to that and get 6885, which somehow I screwed up. So let's go back to my paper and see how we can fix this maybe. Oh, here, right? So I'm not sure where I screwed up here. I got the 3969, right? And then over here, I said, well, there's a common denominator. We're going to add the square of 54. Maybe that's where I screwed up. I think I did that in my head. 54 squared. So that's 50 plus 4 squared. That's 2,500, right? Plus twice 200. Oh, that's 400. Yeah, I think I said 40 for that, right? Plus 16. So that's equal to 2916. Okay, so that means that this here is 2916. One of these days I'll figure out how to do arithmetic, right? So 2916. And so when I add that to this, I get 6885. I suppose that's a perfect square. So we could go to our calculator and ask, give me the square root of that last answer, huh? Yeah, see, that's not a perfect square. Does it have perfect square factors? I don't know. I guess I don't care. I mean, it would be a lot of trouble to find them, right? So if we go back to our paper, then we see that we have to fix some things. Do I have my good eraser here somewhere? Apparently I've dropped it or taken it away. There's another eraser over here. So this is wrong, right? So C is, yeah, this is 6885 here. And so this is wrong. Okay, so 6885. And so we're just going to leave it as 6885. And so when we divide that by 9 to get the eccentricity, we'll get 6885 over 63. Shall we try that? Okay. Okay, so C, so we want twice C, right? So C is the 6885 over square root of 6885 over 7. Twice C is then this, and the eccentricity is going to be this. Let's copy that and paste it in here. All right, let's see if that doesn't fix it. It doesn't. I was pretty sure I had C right. Yeah, so twice C is the focal length, right? We're talking about a hyperbola here. Yeah. And this is C over A, which multiplying C by the reciprocal of A is going to give us square root of 6885 over 63. Yeah, I don't see any problem with this. So let me take this under advisement And I think maybe we'll have to like edit the problem statement, but I don't want to do that now because it'll take too long. Now, that's an inauspicious beginning. Let's go to question 2 and see if we don't get something a little bit clearer. Okay, so sorry about that, folks, but I will try to fix that. It's a homework problem. Okay, so the equation of hyperbola has a center 4, 2 and a focus 9, 2 and a vertex at 0, 2. And we want to find the equation. Okay, so we're given that the center is at 4, 2. That's going to be your HK. So the distance from the center to a focus is going to be 5 units. Do you see that? The y coordinate is the same. And so we're going from 4 to 9. So C is equal to 5. And the vertex is at a distance of 4 units from the center. So a vertex is at 0, 2. That's a distance of 4 from 4, 2, right? So let's go to pencil and paper and see if we can nail this one down now. So they give us that do you say a hyperbola or an hyperbola? Well, we're American, so we say a hyperbola. Has center 4, 2 and a focus at 9, 2. And what else? A running on sentence here. A vertex at 0, 2. So let's draw what we got. 4, 2, 9, 2. That's all sort of in the first quadrant kind of stuff, right? So here's 1, 2, 3, 4, 5, 6, 7, 8, perfectly evenly spaced. Never mind this wider one here. And 1, 2. So here's the center is at 4, 2. All right. That's not a point on the hyperbola, but that is the center of the hyperbola. The focus is at 9, 2, so that's way out here, right? And a vertex at 0, 2, which is here. So this is the distance from the center to a focus. That's half the transverse axis. That's A, and that's going to be 4, right? So then the other focus is over here at 8, right? 4 to the right. And what else do we know? We know that C equals 5 and A equals 4. So C squared is equal to A squared plus B squared on a hyperbola, right? So that's going to be 25 is equal to 16 plus B squared. That implies that B equals 3. So now we got everything we need, right? The center is at 4, 2. So the equation is going to be, and the transverse axis is horizontal, right? So A is going to go with X, and the center is at 4, 2. So it's going to be X minus 4 squared over A squared, which is 4 squared is 16, minus, right? Y minus 2 is the Y coordinate of the center. And B is 3, so B squared is 9, and there's our equation. Let's type it in and be done with it. Any questions about that before we type it in? So we have A is it's a capital A, right? I typically write a lowercase a for that, but that's all right. B, which I usually write a lowercase b for that, is 3. C is the x coordinate of the center, right? And that's 4. And the y coordinate of the center is 2. And resistance is futile. Ah, green checks, finally. Moving on. So here's another one. Oh, this looks like the first one, right? Let's see if we can nail this one. I don't know if it's the same kind of problem, then we're going to have trouble, right? Let's see if we have the same problem here, right? It should go a little faster since we've done it once. Um, so we know. Let's write down what we know. Okay. Um, we know that hyperbola with asymptotes um, y equals 3/8 x plus 7. And yeah, see, we got that same and is butt up against the, no, okay. I think it's going to have the same problem, but maybe I made a mistake on the other one. So I don't know, it seemed like it was right. So the point of intersection of the asymptotes is the center, right? So we have to solve that system, right? The center is where asymptotes intersect, right? That implies that y equals y on these asymptotes, which says that 3/8 x plus 7 is negative 3/8 x. Also plus 7? They're both plus 7, huh? Okay, so be it. And that's going to tell us that 6/8 or 3/4 x equals 0 or x equals 0, right? Okay, well, that's good. If x equals 0, then y equals 7. Okay, so that's the center, right? Center is at 0, 7. So it's on the y-axis. Well, that should make things a little easier. What else do they tell us? The vertices are 14 units apart. The vertices, well, that's the transverse axis distance, right? 14 units apart. That implies that 2a equals 14, which implies that a equals 7. 7 is a recurring theme in this problem. Find the distance from the center to the focus. Okay, so we know that the vertices, they misspelled vertices. Jeez, that's pretty bad. Let's see. So we don't know whether the transverse axis is vertical or horizontal. Did we know that on the other one? I think maybe I made an assumption. Maybe I made the wrong assumption, right? Would it matter? I guess it wouldn't really. It matters as far as what the equation is, but they don't ask us for the equation, right? Can we find C? Well, to find C, we'd have to find B. And the slope is either A over B or B over A, depending on which way the transverse axis goes, right? So if we say so let's put a big if here, right? If the transverse axis is horizontal, then the B goes with Y, and B over A is equal to 3/8, right? The slope of the tangent line, the asymptote. So we know that A is 7, so B over 7 is equal to 3/8. We've got another one of these sort of monster parameter driven things. So it's B is 21/8, and C squared is equal to A squared plus B squared, which is going to be 49 plus 441/60. There I go again, doing things in my head. But I think that's right. The square of 21 is 441. Oh, now let's go to the calculator. I'm not going to do this by hand. That just leads to trouble, doesn't it? So turn it on, clear it out, and ask for 64 times 49, right? That's 3,136, obviously. So then I'm going to add 441 to that. Oh, how did that become undefined? Oh, I typed times 440. I somehow, so I think sometimes it just does that, right? It gives me bogus things. So that's, okay, so we can go back to pencil and paper and write that this is 3,577. It's a nice number, isn't it? Over 64, which says that C is equal to the square root of that over the square root of 64 is 8. So we can compute that. I don't know, does a 3,577 is, that's not a perfect square. So let's just leave it at that. So so this is the distance from the focus to the center, right? All right, and the eccentricity, maybe we should make sure I have the eccentricity right. I think it's C over A, but we didn't really look that up in the text, so let's do that. Where is the text? Here? Okay, I'm going to find eccentricity in here. I think it should be yeah. So this is 11.6. We didn't do the polar equations of conics because we didn't do polar equations. We'll save that for next semester, right? Well, let's find the next instance of that. Yeah. Rotating conics. So I kind of want to go back a distance and say, yeah, find eccentricity from there. All right, so the eccentricity of an ellipse, right? We know that that's C over A. Oh, we're now into the chapter review. What happened to arg? So these are rotated conics. Yeah, we're not doing that either. Thank your lucky stars. Well, I mean, it's good stuff, because we just don't have time. Okay, so if we start out here and say, yeah, find eccentricity. And so they go straight to the unified formula. Okay, so if we go back to our search of the web, let's say we want to find the eccentricity of a hyperbola. Yeah, it's C over A. What did I say? Okay, so we can be confident. I've got confirmation. So what is C over A? Well, A is 7, so that's going to be equal to the square root of 3,577 over 56. And I'm just going to enter in these numbers and say they better be right or there'll be hell to pay. Hell hath no fury like a math professor who's marked wrong. Center of our hyperbola is at 0.7, right? Oh, I guess, yeah, that's two different boxes, one for the 0, one for the 7, right? The distance from that's going to be C, which we said was the square root of 3,577. Oh, I guess we want a close parenthesis, divided by 8. Oh, that's divided by 8. All right, there's the pretty type for that. And the eccentricity is the square root of 3,577 divided by 56. And resistance is futile, so we get those wrong again. I think there must be something wrong. Should we try doing the decimal approximation? Right? So if I go to the calculator and I say, give me the square root of 3,577. So maybe that's, I mean, you have to be cleverer than my open math, I guess. And that's divided by 8 for the focal, the distance from the center to focus. And I get about 7 point, I'm going to enter in this number here is 7 point, notice that it's bigger than A, right? It should be bigger. It's not much bigger than A, but it's enough to make a difference, right? And this next digit is a 0. So if I take that number and divide it by 7, I'll get the eccentricity, which is a little bit bigger than 1. It's 1.068. Okay, let's try that. 1.068. And if I submit now, I still get them wrong. So I think it must be the problem is wrong. Okay, it's good to know. I'll go back and fix it. Match the graphs with the equations. Okay, so there's this one is, it's all about where they're centered, right? So this one is centered at -2. Oh, x is 2 and y is -2. So which one is that? Yeah, that's C. Whoops. And x is 2 and y is 2. That's A. And so this one must be B. Oh, wait. Oh, I see. So there, yeah, there's 2 of them that are centered there. One has the vertices are horizontal. That's A. And this one, the vertices are vertical, right? So that is B. I got lucky. All right. Green checks the whole way. 5. Hyperbola with this equation has an asymptotic equation. Ba. What is the smallest possible whole number values for A and B? Well, let's transfer that over. That's a provocative question, isn't it? Let's transfer that over to our workbench here. So a hyperbola it's x plus 9 squared over a squared minus y plus 6 squared over b squared equals 1. So that's in standard form, but we don't know what a and b are. The asymptote, or one of the asymptotes, is y equals 4/3 x plus 6. So we know that x goes with a, so that b over a is 4/3. And so the smallest value is b equals 4. I mean, it doesn't imply that necessarily. We know the ratio b to a is 4:3, but the smallest integer values, whole number values for a and b is a equals 3. Enter these in. And b equals 4. And those are correct. Okay, but watch out. You may get, since these are parametrically driven, you may get something that doesn't reduce. I don't know. What do we got here? Write an equation for the hyperbola. Okay, so this one, we need to complete the squares, right? And this is good. This may be a problem like what's on the final exam, huh? So let's take it over to, cause it's my favorite topic, completing the squares, right? So we've got 4x squared minus 9y squared. So what do we know from these two terms? If there's any graph at all, it's a hyperbola, right? It may be degenerate though, in which case there is no graph. Minus 8x plus 54y is 113. It actually says minus 113 equals 0, but I'm just going to add 113 on the fly here and get this equivalent equation. So we group the terms involving x and factor out a 4, right? There's 4x squared minus 8x. Factoring out the 4 gives us x squared minus 2x, and it's obvious how to complete the square, isn't it? So for y, we factor out a negative 9, and we get y squared minus 6y, right? Negative 9 times negative 6 is positive 54. And it's obvious that we're going to take half of 6 and square it and add the 9, right? So what, now we have to adjust, right? So we're adding another 4 here, but then we're subtracting an 81, right? So to balance the equation, we have to do that on both sides, right? So we added 4 to the left side by adding this 1 here, and we added negative 81 to the left side by adding that 9 inside the parentheses, which is going to be multiplied by negative 9. So the equation, we're not yet in standard form, I guess, right? But we're getting there, right? So we've completed the square. What is this over here? 117 minus 81 is 36, I think. Okay, so that's nice. It comes out to a nice perfect square. Yeah, so we can divide both sides by 36 and see here's standard form. So this is 4 over 36 is 1 over 9, and 9 over 36 is 1 over 4. So this one worked out nicely, right? Oops, sorry, not visible. Okay. What do they want to know? They want to know where the center is and what A and B are, right? So A is 3, it's the bigger one, right? And B is, well, A, no, it's the one that goes with the positive term. It's on an ellipse, it's the bigger one. On a hyperbola, it's the one that goes with the positive term before the minus, right? Okay, so let's type those in. The center is at x equals 1 and y equals 3, and A is 3 and B is 2. And that is all correct. Am I monitoring the chat? Still says good morning. It's still morning. Oh no, it's afternoon. Good afternoon. Yeah. There. All right, moving along here, number 7. So here we have a graph. Identify A and B for this equation, right? So it's a hyperbola centered at the origin. That's nice. We see that the distance from the center to vertex is 2. That means that A is 2, right? What's B though? Well, we know that the ratio of B to A is 1, right? Oh no, it's 4 to 2, right? They're scaled differently. It looks like if you don't look at the scale properly, you might think that it's 1, but the ratio, the slope is 2, right? So if A is 2, then B must be 4. Yeah. So A is 2 and B is 4. Okay. That was easy. 8. So here's another one where we got to complete the square. All right, let's see if this is any more challenging than the last one, which worked out rather nicely, didn't it? Okay, here we go. Somewhere down here is the top. So we've got 36x squared. I'm going to write plus 360x. So I'm writing the x terms first, right? Anticipating that I want them to be together. Minus 4y squared minus 32y. And I'm going to subtract the 692 from both sides, right? So just did a couple of properties of equality on the fly, setting up for completing the square. So I want to factor out this is going to be a minus, right? Y squared plus 8y. So I put in just a couple of blanks right there. I mean, whatever I put in here, I'm going to have to multiply by 36. And since I'm adding that to the left side, I needed to add it to the right side. And whatever I put in here, I'm going to multiply by -4. So I'm going to be subtracting that from the left side. I should subtract it from the right side. All right, well, this has got to be a pretty big number because it's got the right side should be positive. Well, actually, the right side could be negative, in which case you just multiply through by -1 and you got it going the other way, right? But half of 10 is 5. 5 squared is 25, right? So this is now the square of x plus 5. Half of 8 is 4. 4 squared is 16. So this is now -4 times the square of y plus 4. Okay, so what did I add? Well, 36 times 25, well, 4 times 25 is 100, so that'll be 900. And 4 times 16 is 64, so we're subtracting 64. So what do we get? 208 minus 64 is 144, which is a perfect square, right? That's 12 squared, right? That's good. So we can write this as x plus 5 squared. Let's see, we're going to divide by 144. I think is it 16? So this is equal to 16 times 36, I think, because that's, 4 squared times 6 squared. Oh, no, sorry, 14 times 4 times 36 is 144, right? So that sort of helps us reduce the other side, right? So we'll have a 4 here. And so this one, again, this is designed to work out nicely. Can't count on that all the time, right? But in this one, h equals -5, k equals -4, a equals 2, this goes with the +1, and b equals 6, right? So that's what we're going to enter in the boxes. H is, yeah, -5, right? K is -4. A is 2, and B is 6. Resistance is futile. Yeah, we get all green checks. Let's plot this, okay? If you want to make a graph of this thing, what's it going to look like? Well, it's going to be centered in the third quadrant, right? And so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 will be here. And actually, I think we want to go back just 2, right, to -7, and forward 2 to -3. The y is centered at -4, 1, 2, 3, 4. So here's the center point is here. Where A is 2, so we're going to go 2 to the left of that and 2 to the right of that to find the vertices. The box is going to be 6 tall, right? So we have to go up to 2 and down to 7, 8, 9, 5, 6, 7, 8, 9, 10, down to -10, right? So the box is going to look like this. And we're drawing the diagonals of the box. Those are the asymptotes. Oh gosh, I made a terrible hash of it, didn't I? Well, let's say that it looks like this and like that. Those are the asymptotes. These are the vertices. And so it comes down like this. So that's one branch of the hyperbola. The other branch of the hyperbola looks like that, right? And where are the foci? Well, C, they didn't ask us for C here, but C is the square root of a squared plus b squared, which is going to be the square root of 40, which is 2 times the square root of 10, right? Square root of 10 is about 3.16. So that'll be about 6.32. So a little bit, yeah. So there's going to be a focus over here and over here, right? And we could say what are the coordinates there. This is going to be -5 minus twice square root of 10, comma, -4. And this one is going to be -5 plus twice the square root of 10, -4. Right, just as the XY coordinates of those points, right? All right, moving on. How are we doing? Oh, we got 1 minute. Should we jump on to the last one? So here we've got a Loran radio station. That's an acronym for, I forget what. And A and B, right? So you got these two stations are 130 kilometers apart and send a simultaneous radio signal to a ship. The signal from B arrives 3/10,000 seconds before the signal from A. If the signal travels at 300,000 kilometers per second, I think that's close to the speed of light. I'm not sure. Find the equation, maybe, you know, in a marine atmosphere. Find the equation of the hyperbola in which the ship is positioned. Use coordinate system where the origin is the midpoint between the stations and the stations lie on the x-axis. Right, so we want the center of our hyperbola to be the center of our coordinate system. Okay, so I'm going to set this up here in my pencil and paper, which I'll show you here in a minute. And then we'll do what we can in the remaining seconds. Okay, where's our pencil and paper? Okay, so A and B, we don't know what coordinates are there. We know that those are actually oh yeah, we do actually. So this is -65, 0, and this is +65, 0, because they're 130 kilometers apart, right? So these are the foci, right? So this is actually C0 and -C0, where C is the distance from the center to a focus, right? The hyperbola looks like this, right? And the ship is on the hyperbola. And it's getting a signal from here and a signal from here. And the speed, let's say velocity, is 3 times 10 to the 5th kilometers per second. So the distance from, this is going to be D1 and D2. And we know that the difference between those distances is we know the difference between the times, okay? So time 2 minus time 1 is time is velocity divided by distance. Is that right? No, distance divided by velocity, right? Yeah. Yeah. Distance divided by velocity. That's the general form, minus the same thing. Okay, so the distance d2 divided by 3 times 10 to the 5th minus the distance d1 divided by that same velocity, right, is equal to 3 times 10 to the negative 4th. Just using some scientific notation there. So we want to multiply both sides by 3 times 10 to the 5th, and we get d2 minus d1 is 990. So what does that tell us? The difference between well, I'm going to have to write this one up because we're way over time here. So I'll write it up and post it in this week's module. Okay, and then I have to go to rush to my office hour. So yeah, we kind of did some review today as part of, work on these problems, but I think it's sort of important to woodshed on hyperbolas a little more because they are sort of more difficult than the other conic sections. Okay, and we got some funky numbers going, and I have a few things to fix up for you. So any questions before we break?
Yes, Professor, I was wondering if you could post the class recordings for the past few days.
Oh, yeah. So are we missing those? Let me take a look. I guess I have to go here. Trigonometry. So there's, so what happens is, so today is the 9th, right? So yeah, that works. Okay. And how about this one? Yeah, that seems to work as well. It's an event. Okay, so I think they're there.
Okay, is that just the link on Canvas, or can I like download it from ConferZoom?
Well, if I go to ConferZoom and click on event recordings, I see that there's one for today, actually. So can you download these here?
Yes, there's a MP4 link, but it has to be posted on there, and it usually says like check for recordings, but it'll like that specific date will be posted on Canvas, but it won't be on ConferZoom for me to download.
No recordings exist for this event.
Yeah, that's what it tells me.
Okay, I see. So that we do have them here for Monday, but not for Tuesday. And I don't do this. This is not my thing. This is supposed to be done for us. And it looks like they're a little bit behind. I guess you can stream it, but downloading it seems to be, it's probably better quality if you download it, huh?
Yeah, it's better, and then I'm able to like scroll through it at my own pace, and I don't have to like mess with the like hour-long little bar that's
that
really
must be a
sensitive.
lot more convenient.
Yeah.
So I will inquire about that because this is not something I can do. So Monday is there, but Tuesday, not. So let me ask about that and I'll get back to you. All right, so we have tomorrow. All right, anybody else?
Professor?
Yeah.
I was wondering if there was a possibility that you can extend the solving triangles homework. I've been really busy and I actually didn't get to it yesterday.
Yeah, I'll be glad to. So let's see, if I go to assignments and say homework, I think they're in sort of chronological order here. So solving triangles. Let's go to okay, I think maybe I clicked on the wrong thing here. Yeah, I think I have to click over here and say edit. Okay, and then I can set the time, and let's just, push it off for a week. As long as you get it done, I don't really care. I think our exam is a week from tomorrow, right? The final exam. So just do it before then, right? That's what counts. And
Thank you so much.
you're very welcome, Mary. Anybody else? All righty. We'll wrap it up there, and I'll follow up on those loose ends.